Well, good morning or good afternoon, depending on wherever you're at. Welcome to our webinar called Precision Repair for Wind Blades. We're excited that you're here. We've got some special guests here in the room with me, and we've got a really interesting kind of multimedia package where we're going to show some video that we shot of the blade repair process, and then add some insights from process expertise and from some material expertise with Gentry. And so I think it'd be a really fun dialogue that we're going to have and share with you. While we're doing that, if you have a question, just type it into the screen whenever you've got it. If we do this right, we're going to be sharing some insights and content for about 40, 45 minutes. And at the end, we'll try and answer as many of the questions that come in as possible. Kind of expecting a diverse set of questions, actually, Alfred and Gentry, because we have a pretty wide set of skills and people that have joined us today. We have on-blade technicians. We have their peers, so people in the office that handle logistics and materials and things like that. We have ISPs. We've got some asset owners. We've got some OEMs, a number of vendors, and then also some of our C1 peers as well that focus on wind business. So it's really kind of a diverse set. So I'm curious how many new things we're going to show them today, some good things that we're just going to reinforce, and then we'll kind of get to that Q&A session at the end, what kind of questions they have for us. So as we get started, give you a little peek at what we're going to do. So we'll do introductions in a moment, and then we're going to start with safety, and specifically a look at PPE, and then do a tool overview. Now we have some video content to kind of back that up that we recorded in Alfred's Blade Repair Academy a couple months ago, but we've got the tools here, and we've got Alfred here, so we're going to get a live version with some video kind of playing in the background. And then really the heart of what we're going to be doing is from that point forward. So scarfing, layup, compaction, fill and fair, top coat. That's for basically what we've got is video and some insights from the first time the blade tech touches the blade in the repair process until that final roll of top coat, and basically the entire sequence in between. A couple of minutes of video to kind of highlight what's going on there, and then some good observations and some dialogue with us as we're kind of going forward. Okay? So with that, my name is Brett Anderson. I am the Power Generation Market Manager for Composites One. And so if you build a wind turbine blade in North America, or if you repair them, me and my team are aligned to help you solve your problems and make sure that you have the materials that you want, where you want them, when you want them. So that's me. Our guest today, Alfred Crabtree from Blade Repair Academy. Alfred, can you introduce yourself?
Sure, thanks, Brett. My name is Alfred Crabtree, and I am the CEO and co-founder of Blade Repair Academy. Our facility is located in Dunlap, Tennessee, which is near Chattanooga. We have a facility dedicated to teaching the art and craft of doing wind turbine repairs.
Okay.
Blade repairs.
And how long, Alfred, have you been in the wind repair or blade repair business?
I started 10 years ago, Brett, working with Rope Partner as a blade technician, rope access technician. And then I spent 2 years at Wincom as their training development manager. And at that point, I realized it's probably a good idea to set out my own shingle and start a school specifically for training the composite repairs. We're not interested in your access method, and there's a lot of corporate training and safety training that others do really well. We focused on the composite repairs.
Okay. And for those of you that are joining us, hopefully you saw some of the LinkedIn teasers and the announcement we made about this presentation. We had a special feature with Alfred. His video of actually descending a blade, doing a repair with rope access. Really cool video to watch, and it kind of gives some credibility as far as how deep you've been in this business and how well you understand these processes and the issues that these technicians have that we're going to try and address with some of this conversation.
Great.
Okay.
Great.
Gentry, how long have you been with Composites One?
I've been with Composites One for 16 years and on the power generation side for 13 years.
13 years.
Mm-hmm.
And I've been teasing Gentry as we've been getting ready for this, because my guess is, I know that Gentry's been working with wind repair companies for more than a decade,
Mm-hmm.
but that probably most of you have received an email from Gentry or sent one to her asking her to help kind of solve a problem for you. So you probably know if this is the first time you're seeing Gentry live, this is Gentry. And so we'll have fun as we go forward with the rest of this presentation. One thing to note, so we're going to share some video as we talk through some of this stuff. It's really an interesting perspective, because what we have is we have the master, the teacher, who's very experienced with these things. And what you'll see in the video is that Gentry's actually the person doing the actual scarfing. She's doing the mixing of the resin. She's doing the top coat applications. So from somebody who's very experienced to somebody who's maybe experienced some of this for maybe the first time.
First time.
And so we'll get some insights and comments from kind of both as we go forward. Okay? So what we're going to do first is look at PPE. And we'll show some video. And Alfred, if you can just kind of talk us through those key components for safety and some insights, and then we'll kind of step from there.
Sure. Yeah, PPE is very important. Professionals protect themselves. That's the first thing to note. And your first impression on site is important. Your safety guys want to know that you have your equipment, so let's get equipped. We like to start with the Tyvek suit so that we can protect our clothing and ourselves from the contaminants that we're going to experience. You're going to have up tower grease and grime, and you're going to have chemicals and dust from doing the repairs. Take this off and don't bring that dust home, okay? iPro is really critical. You see Gentry and I have on our standard iPro for basically anything that we're doing, we want to have at a minimum that type of iPro. Here we have some goggles, and you would use goggles when you're using your half-face respirator. Now I'm picking up a PAPR, which is the Cadillac, right, Gentry? The PAPR pushes air into your face and helps keep your lenses from fogging up. If you have glasses or facial hair, it's great. A full face respirator is a good compromise between the two in terms of iPro, and of course you're getting your respiratory protection at the same time. In the wind environment, iPro is super important because it's windy, and that makes things fly around. So if you're up on blade and it's blowing 15, 20 miles an hour, let's have some good sealed iPro on when we're working with chemicals or abrasives, right? Another thing that we often neglect is hearing protection. And obviously we want to continue to hear well into our older years, but what we can really benefit from using Hearing Pro is it reduces your fatigue while you're operating the tool. So that time you're spending up on blade, anything we can do ergonomically to make it easier on us, it's going to reflect in our work. And then we're talking about gloves. We have 3 basic types of gloves. The ones I'm wearing are like your dexterity mechanics gloves, your general protection. The nitrile gloves are for when you're using chemicals and you want to be able to dispose of that contamination immediately. And then we have some cut-resistant gloves for when you're using the power tools, specifically the grinder.
Okay. Thanks you for kind of walking us back through that content. The thing that really surprised me, I guess, is I know we want hearing protection because we want to hear as we age, but for the fatigue reduction is there's an impact on that, allowing a technician to work longer, harder, better, less fatigue at the end of the day? Absolutely.
Yeah, we're in a highly stressed environment when we're up there. And so your attention span really, moves in tight, and you have to stay tightly focused on what you're doing. And any distraction or anything that can make that work harder for you is going to be reflected in your product. So at Blade Repair Academy, we teach a lot of things to deal with the ergonomics of the situation and make the technician's life a little easier and more productive.
I think you saw some of that with even the gloves. After running some of the tools and wearing the right glove seemed to make it less vibration, more comfortable, work longer.
Yep, of course.
Mm-hmm. Yeah, the newer cut-resistant gloves that are fabric and instead of leather seem to have a little better fatigue resistance, some cushioning.
Cool. All right. So thank you guys for those comments. So basically kind of give a little rhythm for what we're doing. So we'll have a little video when we'll be talking about it, a chance to kind of emphasize anything. And then at the end of each little vignette, we've just got a slide to kind of highlight some key takeaways from a material perspective and from a process insight. So this is the pattern you're going to see over the next 30, 40 minutes or so. So either one of you want to kind of chime in on this?
Yeah, so just to recap on some of the PPE, you have your half face, your full face with your cartridges, along with the PAPR, and then your nitrile gloves for easy and convenient and disposable, and then your cut resistant gloves for when you're using the power tools.
And so Gentry, we filmed all of this on some blazingly hot days in the south side of Chattanooga, Tennessee, back this summer. Your experience with the half-face respirator and the PAPR as far as comfort or experience, what were your thoughts?
Yeah, so it was very hot that day, and in that building, it was hot. The half-face, you could just feel the sweat underneath. The papper was really nice, as there's a nice cool breeze coming through the papper when you're working. So
The papper is a game changer. It's a real game changer. In wind, when we're working on this transparent material, being able to see it is critical. And we have enough challenges with dust and everything, but if you're super hot and you're fogging up your lenses, it's...
And am I correct that this is almost state of the art in Europe, or
Europe,
as far
it's
as some of your technicians have kind of gone to that as kind of a go-to as opposed to the half of the
Yeah, I
full
think
face?
it's almost standardized in Europe. I have one, and I really treasure it. I use it for the subtractive abrasive processes. In our work, where we're doing chemical work, we're usually outdoors, and so a half face and some goggles is suitable for that, unless I'm fogging up. If I'm fogging up, we have to do something about it.
Okay, very good. All right, so safety first, always.
Yeah.
So next we're going to take a really unique look at an overview of tools and really a specialty for Blade Repair Academy as far as kind of the subtractive methods that go into doing a blade repair.
Correct.
All right,
Yeah.
so we'll kind of roll to the next one here for this tool summary. And while this is running, Alfred, if you want to kind of demonstrate some of the tools.
I do.
or talk-
I'm passionate about the tools that we use. The primary tool that's used in blade repair is an angle grinder. This angle grinder is a rat tail grinder, which means it has an extended length handle. The diameter is super small so that you're not having to deal with a barrel grinder that has a really big fat hand grip. This little knob here is a pivot point that we're going to place on the blade. Contrary to popular belief, handles and guards are features that help you do a better job. You can be more precise and have less fatigue if you use the handles appropriately. And this is a technique that we like to teach.
We'll see more of that when we watch the actual scarfing processes for how that's used.
Yes.
Highlight some of that stuff. Okay.
This runs on a 36 grit abrasive disc. I really like the 3M 782C. It's aggressive. It's long lasting. It comes in a nice package that has a Ziploc, and that's a kind of a pro tip is these things they warp if they're exposed to humidity. So keep them in their sealed packaging until you're getting ready to use them.
Okay.
Okay. This has a trigger. It's either on or off, and it's only got one speed, and it's powerful. So this is our coarsest, most aggressive tool. Okay.
So you move from that to?
The next tool that I want to talk about that we introduce is a pistol grip. A pistol grip sander. And the pistol grip sander is a good intermediary between the grinder and the random orbital. The pistol grip sander, again, we advocate the handle, is a lot like the grinder, except that it has a throttle. So you can choose how fast you want it to spin. It has a soft backer pad so it can flex. And we run abrasive discs.
So
instead.
that speed control and soft backing allows you to be more gentle or more precise with what you're trying to.
And it conforms to the shape of what you're doing. I find the most use for this tool when I'm fairing my filler.
Okay.
And this actually features, it's a big feature in our strategy for filling that we'll get into a little later. Good time to talk about this new product from Mirka. It's the Galaxy line of sandpaper. This is a ceramic, like a engineered grain.
Okay.
Super aggressive. I like it in the no-hole version on the orbital sander because this thing spins and it's going to eject what this is abrading. And like this 40 grit, it comes off in shards. It's not even dust. So it's really aggressive. But then we can move all the way up to the 120 grit. And the 120 grit is fantastic too. So this is a great tool to kind of bridge gaps. Okay. The third power tool that we like to use is a random orbital sander, and you should invest in a high quality one like this Mirka Deros. This is a brushless motor. It's extremely well balanced. This is again one of those ergonomic things where an inexpensive sander doesn't have the engineering to prevent that fatigue. This is super smooth.
There's a theme, and a lot of what you're talking about here is being fatigue reduction, so working being longer, more comfortable, not being worn out, or quality that kind of drops off with fatigue.
And by introducing intermediary tools and a progression of grits, we're able to be more productive and quicker, which is, we want to hear that, right? So
Okay.
a good random orbital sander, like this Mercaderos, is a great choice. Another tool that we introduced, it's not like it's, unique or new to us, but we really have a firm belief that a little belt sander like this, a 1/2 inch by 18 inch, 80 grit belt, is fantastic for plunging and shaping core. We don't have to turn everything into dust. As you know, when we're repairing, we're actually going to remove a lot more good material than bad. But if there's a lightning shot and you have an expansion event, and there's a shell sticking out, you can cut that entire thing off.
And just basically take a chunk off rather than pulverizing it.
Yeah, if you're pulverizing it, you're taking a lot of time when you don't necessarily need to. We have a theme, which is you go from hog to precision. Hogging is quick and fast, but of course you have to stop before you get into critical areas, and then precision is the mode you shift into. And these array of tools allow you to do that. Okay. And the last tool we're going to talk about today, and certainly not the last in the tool set, but the Dremel is very common with the stone on it. I like to use structured carbide bits. They last longer, but basically this is going to get you into the corners and into little holes and bubbles and pockets that you need to remove the shine or clean up before you go ahead and apply some material.
Very good. That is a great summary of the different tools that you work with on a blade repair or something like this. You talk a lot about using the right tool. It eliminates or reduces fatigue. The thing that kind of rattles around in my head, Alfred, is this idea of pairing the tool and the abrasive for the job. Yeah. So whether it's, if you're hogging, you want the right angle and you want the fiber disc. Then as you get into the random orbital or the DA, that's the tool changes, and then you still can step from 40, 60, 80 to 120, or there's still a grit range depending on if you're removing material or doing fill and fair, finish and fair, and things like that. And we'll see these tools with those kinds of commentaries as we get into the actual repair process that we're going to start here in our next module.
Yeah, we at Blade Repair Academy, we like to emphasize that quality tools and quality consumables like your abrasives really pay off, in the profit margin. We spent years buying inexpensive sandpaper, and I just got sore. And I figured out one day, let's buy the good stuff and run it on good tools, and we saw productivity gains that really make a difference.
Well, it's nice to know those options are there for us now for all these techs that are on as well. So
correct, yeah.
Okay.
And this was the first time that I had used a couple of these tools when we were at Alfred's shop, and he was a really good teacher, especially with the angle grinder, just showing me different techniques and how to use it. And
thanks, Gentry. Our program is set up for new people. Like, we have an easier time with people who've never touched the tools than people who have habits.
No bad habits to break.
Right.
So do you have a right angle grinder in your barn at home now that you practice with and you go play with?
I do not. No.
Not yet. Well, Christmas is coming around next year, so we'll be good for that.
We'll remember that.
Yeah. Okay. So grinder most aggressive, and then that pistol grip. So there's a sequence to the tools and a sequence to the abrasive to kind of do the job as most efficiently and highest quality as possible. Okay. So these first two things that we talked about with safety and the tool overview were kind of foundational for everything that we're going to see next. And so our next thing that we're talking about is scarfing. So this is, again, the first time the tech's going to begin the subtractive process. We're to get rid of a lot of good material and the bad material so we can get it to a point where we get to that bottom of damage.
Correct.
And then start to rebuild from there. So, but the first thing here is the scarfing. So we're going to run this now. And Alfred, if you could kind of give us a little coaching or guidance as we go through it, that'd be great.
Sure. Yeah, what you're going to see on screen here is basically this same panel here. And when we are working with the tools, what we're going to want to do is expose each layer enough to put a patch on it. So that's what scarfing is. And in fact, when you're scarfing, you're removing more good material breadth than you are bad.
Yeah.
The hole may be this big, but the scarf is going to be this big. This is really where the rubber meets the road. This is the craft. This is the bottleneck of getting repairs done. People with the right skills being able to make this step happen. Okay. So this is where we have the most productivity gains to make. Okay. So right here, I'm demonstrating to Gentry. She's going to pick up the tool in a minute. Some of the more common ways that we want to use the tool. If you notice, my tool use is I'm putting it into the material and then moving it in one direction and lifting it back off. If you're putting the grinder in and moving it back and forth, that's called scrubbing. And when you're scrubbing, you're creating low spots in the corners where you make that change of direction. So we want to avoid that. Here I'm chasing this line up.
Always start and pull. Always the same direction.
It's a pull, right. And you want to pull towards the center of the layer that you're working. What you're not seeing here is that we really want to work from the inside out, so the deepest layer gets done first, and then the shallowest layer gets done last. And there's reasons for that we can go into at the academy, but it's a time saver to do it that way. So both hands are touching the blade. The bump at the bottom of the grinder, this little nub, is a pivot point that we can use to control our tool. The environment that we're working in is dynamic. I'm on rope, the blade's moving a lot. Sometimes the blade can move 2 or 3 feet because it's so long. And you have to engage the blade with your hands to gauge the tool as you use it. That's the secret sauce. Hope I didn't spoil it by sharing it with everybody.
There you go.
Yeah.
So we're done.
Yeah.
We're done.
So now Gentry's about to pick up the tool, and she's going to take off this second layer here. She's going to take off top coat and 1 layer of biax. I've removed 2 layers of biax and top coat before. So this is her first actual touch of the tool. And she listened really well, and we did some dry work on the table, managing the stroke. And one of the things she picks up on while we're in this facility is the noise. Like what the sound of a good grind is part of that learning modality that we try and emphasize. We try and teach in a lot of different modalities, but the soundtrack of running the tool is helpful, isn't it?
Yeah, it really is.
It's interesting because you mentioned that, and I know also I've heard you talk about kind of you can feel your hands are good eyes as far as
They're better than your eyes. You need to shut your eyes and let your hands gauge. And I'd like to, we're in our grind booth at our facility. We have 9 horsepower of dust extraction in this room. There are 8 bays for people to work on, well lit, all the power we need, and all the work you're going to do is in the vertical orientation, which is most like what you're going to
simulate
encounter.
real life as much as possible.
Right. We built this facility to mimic, other than it's got a roof over your head, it's built to mimic the conditions you're going to have in the field more so than a composite
It's nice
shop.
that you don't air condition it so that it feels like you're really outside.
Well, if you're going to pull that much air out of your space, it'd be silly to air condition it first. And that's true. You dealt with the heat that the technicians do in the field.
Yeah,
right?
it was hot. I mean, being in that building, so just having a better appreciation for the techs that are actually up outside on the blades doing the work every single day. So
Fantastic. All right. So as we kind of highlighted at each section, we're going to kind of just pause for a second. Just the wind scarfing, the fiber disc is the go-to tool on the right angle grinder.
Yep. And then
most effective.
Your cut resistant gloves are really important when you're using the power tools as well.
For safety and for comfort and
safety,
fatigue
comfort,
resistance, things like that.
durability.
For fatigue, we use the right gloves, high quality, shock absorbing gloves, and that the rat tail grinder. Take a look at that if you've never used one. If you've only used a fat barrel grinder, try the smaller grip on a rat tail. You'll find that you can work a lot longer.
Fix it onto the blade gives you a fulcrum or a pivot point to make it all better quality, easier, less stress as you kind of do those kind of things.
Correct. Yeah.
Okay. All right. So again, we started with safety and with the tool overview. This is the subtractive process. So we basically have gotten rid of the damage and a lot of good material. And now we have to pivot and change from taking things off, starting to build back the material and the integrity of the material. So we're going to start this with a layup process. And again, we'll just kind of roll the video while we're talking. And
sure. What we teach at Blade Repair Academy is what we call wet layup. And in wet layup, we're going to take each layer and separately apply resin to it underneath some plastic. And when we do that, we're separating each layer into its own batch of resin. And now in this case, the first couple layers were so small we included them in one. But we were able to stage each other larger layer with its own batch of resin. Now this may seem like a lot of extra work. The alternative method is dry layup, where we slop a bunch of resin on the blade and we throw the dry laminates up there and wet it out. It's very messy and it's reliant. You're using one batch of resin, and then whatever the pot life of that batch is, the time you have to complete the repair. And that's going to affect quality.
Yeah.
By doing it with wet layup, we can make improvements in quality and stage each layer separately.
That staging was interesting because I watched you two work while we did this. So Gentry represented the ground support.
Mm-hmm.
You kind of represented the up tower,
Mm-hmm.
and kind of batching to be able to do the first 2 or 3 pieces based to control the not the shelf life, but
The gel time,
the
pot life.
the pot life of the gel time,
Mm-hmm.
so that as the on blade guy, you were ready for those, and then you hollered, okay, now give me the next one, and it gave you the maximum use of the pot life of the material.
Mm-hmm.
For less stress
Mm-hmm.
during the actual layup process.
That's right.
Mhm.
Mm-hmm. Now, one thing that we saw here that we haven't talked about yet, Gentry, was you were a little confused about why I was so adamant that we spend so much time on mixing, right?
Yes.
Yeah, it's a very critical step to mix your resin correctly. To have all this planning and all this stuff fail because you didn't incorporate the components well is a big deal. So Gentry got a little lesson here on plunge strokes and wall scraping and cleaning, and then 200 strokes and maybe a couple hundred more, right?
Right. Yeah.
Right.
So here we are now on a really quick time lapse of the layup process. And in a nutshell, we take 2 pieces of plastic, put some glass between it, wet it out in there. Our hands don't get dirty. And then we can apply the layers like stickers
One on top of
to the
other.
repair.
Yeah.
Right. This allows us to, in a multi-layer repair, I can stage the gel time for each layer and take some time in between them. And that allows them to set and get secure and not slide. It also allows me to separate the exotherm. If we have 8 layers that we put up all of a sudden, they're going to accumulate that heat all at one time. So we can sort of take that extra energy and spread it out over time. And let's say we get a lightning alert and we're at layer 4. I didn't just blow 6 kilos of resin, and I can just ask my support person to send me up some peel ply, and I can put it on and continue. So there's a lot of value in wet layup. The biggest one is that my support person is part of the repair. Because if you're doing dry layup, your ground personnel may not have anything to do with that. And so they're not going to learn. And in this case, I can spread out the workload. We can tackle more complex repairs by distributing the workload and staging things separately. There's a lot of wins.
The staging almost de-risks some of the mistakes or the sins of going too fast, or
Correct.
or trying to take some of the pressure off. So it's a good approach.
That's right.
Okay.
Now here we're applying a vacuum bag, because we're going to compact it. And we've put this into the layup video because the clock is running, right? And our hands are dirty, and so this is still really part of the layup process. But this board right here is the board that we laid up on. And these are the materials that we're going to talk. Should we do this now or on the next slide?
Your choice.
Okay, well, I'm excited about these materials, so let's talk about them now. When you're bagging, you can see here I have everything staged because my hands are dirty, the clock's ticking. It's not like I have shelves, okay? My knees are right down here against the blade. So this is a common setup. We have our 400Y vac film up top, which is going to seal the bag. We have our gummy tape underneath this blue tape. The blue tape is protecting it from resin while we're doing our repair. And then when we're ready, we can deploy our combi. This is a product that comes from the infusion world that I think is super beneficial in our repair program. Combi has an infusion mesh with a breather and a peel ply all in one. So if we were going to stage this without this product, we would be setting 3 separate products underneath here. And that just gets cumbersome.
Yeah.
So that was super easy.
So controlling one layer, you're taking less up. It just, again, de-risks and improves the overall quality and the speed and efficiency. You can kind of set this up.
That's right. This material right here is connected to the vacuum hose, and this is called VMS 3. And VMS3 is a membrane. I want you to think of it like the Gore-Tex in your North Face jacket, okay? The bottom layer here, this is the membrane. So this will allow air to come through, but resin cannot come through it. In the middle, it has a mesh so that it can communicate vacuum across all of it. Makes sense. And then it's got a plastic film on top, and you seal this thing off with gummy tape, a couple feet of it on top of a repair this big. It's going to extract all the air from inside of here. No resin will get through, so you're not going to dry out your repair. You don't need a catch pot anymore, and you can run a smaller pump on blade. So these two items in combination with the 400Y just makes for a wonderful.
These are enablers that really help the overall quality and efficiency of the job. Now, I know you said that the method you lead or you teach it is a wet layup. Most of these materials were designed or intended for vacuum infusion. So do you see more of that coming, or is this kind of one of those happy coincidences, or what are your thoughts?
Well, we arrived at this because we've developed an infusion curriculum, and in doing that, we did some research, met with you guys, and started to find some process materials that suited us. When we're doing on-blade repairs, we're not super worried about pleats and things like this, at least in something like this, because it's relatively flat, and having it cure flat is great. So deploying these materials in this package right here, just imagine you're the only guy up on the blade. It really eliminates a lot of problems.
Okay, cool.
So during the layup process, we used a wide variety of materials, from chemicals to consumables, which we keep a wide range of materials in stock. As we know, you guys use a lot of consumables out in the field.
This is the process that does.
It was eye-opening for me, Gentry. I don't know about you, but to see how much, even in that mixing process, even how much stuff is used to make sure that everything is clean and appropriate. It was like, oh, this is why we have warehouses full of this stuff, ready to go out.
Yeah.
It was just
Sometimes we wonder, like, do you really need 1,000 stir sticks? Yeah, you really do.
You do. You do. Yeah. This is the step that teamwork and coordination really pay off. And that's why we teach a support and a lead role, because together they create a team, and we want to create value for your teams from the initial hiring moment that you've got somebody in there, all through their career.
Okay. So we had vacillated, Alfred, on showing or talking through these in this last step or the next one, but we're going to roll on to compaction now, which is really what all these materials are helping to do effectively on the front end.
Yes, exactly. In the compaction, the vacuum bag would be deployed, and a seal would be created and nurtured, let's say, because that's something you have to kind of finagle.
Yeah.
But you can see here we've got a bag under vacuum, and Gentry and I are talking about what's happening in this case. The exotherm is occurring in the center of the bag here. We have let it gel before we kicked it on, and that allowed us to ensure that it wasn't going to slip in position and it wasn't going to overcook. We have to manage when we put our post-cure heat in here, because if we do it too soon, you can cook the material before it's gelled, and then bubbles can form, your core can turn colors.
And as you explained, as far as kind of managing that gel time with the wet layup process, allows you to get layer 1, 2, 3, so they won't slip and slide. So basically, you have better stability of the correct placement of your materials as you build on top of it by doing that controlled method, and then kind of
better management of the heat profile, the heat curve, right? Because we don't want it to spike and then throw additional heat on it because we're trying to get out of there. So we want to manage that. And if we can manage it while we're doing the layup, then when we get to post-cure, there's that much less work to do. I'd like to mention here, because we're about to put the heat blanket on, but one of the products that we used was Sika bi-resin. And we like that in the repair schema because it has a very short post-cure time. It's under a couple hours. So time is money in this game. If we can get post-cure done and top coat in the same day, as opposed to having to post-cure and then come back another day to top coat, that's a little benefit that we want to take advantage of.
Okay.
All these little gains add up.
Yeah, I can see that it is a creature. So they've given me the time sign, so like we're diving in here, which I think is really good, but I want to make sure that we get through. So we have done all the subtractive steps. At the end of this process, now we have the structural integrity
Right.
is there,
Mm-hmm.
and so we have 2 steps left, basically, filling and fairing, and then top coat. So
Mm-hmm.
just in the interest of time, so we have some time to answer questions at the end. I'm going to move us along just maybe a little bit
Sure.
faster
Sounds good.
without trying to cut things off too much. So
BMS 3 and Combi.
call Alfred.
Call me.
And then I think you were talking about using improperly ill-prepared substrates can be a nightmare.
Yeah,
And
any vacuum compaction, if you don't have a good seal, you're going to have problems. This is even more so with infusion. So mastering this and incorporating these materials into your technique is going to pre-stage you for that infusion training.
Fantastic. All right, so we're going to move right along to fill and fair. Oops, not quite that fast. How about that fast? That'll
Okay.
work. That works. Operator error. So this is where you worked really hard, Gentry. Is that right?
I did, yeah. I felt like fill and fair was the hardest part of my job at Blade Repair Academy.
Filling and fairing it's the first thing that a support person learns to add value to the repair, because once the structural is done, we're not so worried about learning mistakes. Okay, but
Well, and you have a lot going on, right? You're holding the spreader, you're holding the material as you're dispensing it or rolling it.
It's fickle, and it's a fickle process, and the chemicals that we use are the most fickle set of chemicals that we use. I don't know why, but they are. And what we teach at Blade Repair Academy, we want you to use the fastest chemicals you can, and you're going to apply them 2 or 3 times. The other method.
Here's this first, just as you're talking, keep going, but
Yeah,
I'm just saying, for those you watching, so we got this first coat, because it's a multi-coat approach.
It's a multi-coat approach, right? The other method would be to use slow materials and get it all on and expect to sand it all off in one go. Well, you're going to wait an hour or 2 for that filler to cure, and I've already been through 2 iterations in that amount of time. So it's a little bit of a pain in the butt to use these rapid cure materials, but it's worth it in my opinion. Okay, so we work on getting it on, and then we're going to take that aggressive pistol grip sander and flatten 80%. And knowing that we're going to go back and touch up and then take another whack at it. And we have time to even take a 3rd whack at it because we've been so quick and efficient. We're not feeling the pressure to get off blade.
And
so we can really make it high
a 2 or 3 step process is actually faster than put a bunch on and try to fight with it.
It is, but you have to adapt to the fast chemicals. And when you're in the field, it's not a time to take on new skills or new materials. Somebody sends me something out in the field, I'm used to something else, I'm on the clock, and I have a bad experience with it, I'm over it. I won't touch it again. But you come into the environment of the academy, and now that pressure is not on, and maybe there's 8 of you trying to learn the same process. There's a lot to gain, and that's how you get new ways of doing things into your workforce.
Okay.
So we've done the first coat and applied it.
Mm-hmm.
And now we're going to get super aggressive with that pistol grip sander. This is technique. And again, you need to try it. A lot of people are a little intimidated by that tool, but you have to rein it in. You have to manage that tool.
Well, one thing I noticed using this for the first time was at first I was kind of fighting the tool, but then by the end I was letting the tool do most of the work.
That's right. Yeah. One of the things we teach at Blade Repair Academy is a hands-on approach to the tools. There's some insight about how to use the sanders. Mm-hmm. We don't press too hard. We change discs out often. We step through the grits.
You tune the abrasive for the point you're at in the process. You let it do the work while you kind of guide the tool.
Mm-hmm.
That's right. That's right.
Okay.
Spreader work is a huge part of this. Angle of attack is something that we talk about, right?
Yes.
What angle are you going to hold it at? And there's ergonomic issues. If I'm moving up, my hand wants to swipe. My hand wants to change an angle. So maintaining the angle as you go through it is important. And that means knowing the limits of your body, especially when you're on rope. Your area that you can work is small, because if I push out here, I'm actually pushing my body off a blade. See what I'm saying?
So maybe a different technique from a platform as opposed to a rope, but knowing that. Okay.
Yeah, we try and focus on not necessarily rope access technique, but we come from rope access technique, and we have the least amount of resources in that technique. So if you can learn the way we do it, you have a little more freedom and opportunity when you're on a basket or a platform. Like you can have extra people. On rope you don't. So if you can master these techniques, then it's going to make your work easier no matter what access method you're using.
Okay, good.
So there Gentry's put on the second coat, and you can see it's messy, but I don't care because I'm going to attack it with an aggressive grit. I'm not shaping it with the spreader, I'm shaping it with the sander. Now Gentry and I are moving in to the second phase of sanding, and in that case we're going to move into the orbital sander. And there we have the Mirka Abranet, which is the mesh that can extract dust. And the Mirka it's not hooked up to a vacuum typically when we use it outdoors, but it will pull dust through it and spit it out the little pipe. So 80 grit, 120 grit finishing papers, the Abranet in the Mirka family.
On that second pass, you're kind of working on to kind of get that final surface level.
Here I'm just taking the pistol grip to knock down those ridges real quick, and then I've moved over to the Mirka. And it's about processing. It's kind of hard to tell in here, but there you can see some of the swipes where you want to lawn mow it, right? You want to make sure you cover everything. And that's just, again, more of that
technique and getting experience and getting comfortable and using the right tool with the right abrasive on it.
Yeah, you're done with the grit when you can air hockey the tool. You remember that? Like sometimes it grabs somewhere. That's a good point. Then you need to keep working that until it doesn't grab anymore. If you get that with 80, when you move to 120, it's 3 or 4 minutes. And move to 220, it's 3 or 4 minutes. So stepping through the grits is important.
That's great. So finish with this last. I think the video is just kind of wrapping for that part, and then we're going to go to kind of finish this. Again, this is what we've been talking about. Is we talked about gloves. We talked about the spreader is something. I watched you guys work, and your comments. Spreader and angle are important. Mixing are important. So it's these details that seem far removed from the glory, glamour, or treachery of being, but those little things make a big difference on the overall quality and efficiency and how fast you can work and how the overall quality of the project that you get.
Yeah, and I think a lot of that has to be shown to you.
Yeah. Okay. So structural parts done. Now this is the icing on the cake. This is the final piece, the top coat. And I know, Gentry, this is another place where you worked pretty hard as well.
Yeah, I did. I feel like going into it, I felt like it would be as easy as painting a room in your house, but it's not that easy, especially when you're talking about the wet edges and the flashing of the material and trying not to overwork it. So
yeah, the household latex doesn't dry very quickly. You're not in the same environment. But the theme here about top coats is the difference between top coats and the other materials that we have is they have a solvent base that is intended to evaporate out. And we need to take advantage of that flashing and not abuse it. So typically what will happen is you're going to apply your top coat. In this case, we got this nice sponge roller and a squeeze bottle of paint that allows me to apply it straight to the blade. And we're going to really work on just getting it on the blade. Okay. In the wind, in this case, if I'm dipping my brush over here and bringing it over here, I'm probably spraying paint everywhere because I'm in a windy environment. So this is a great way that everything's in contact with the blade.
But one thing you taught me was you don't want to just put a bunch of top coat on all at once, because then your roller's not going to do what you want it to do.
That's right. We want to listen and read our roller. If the roller is pushing and not spinning, you have too much on. But I consider that bulldozing, so I'll spread it, and then I'm going to use light touches to get that roller to start spinning again. Okay. At that point, I'm going to take out the gross tool marks, but move on, because what we want to happen is that ugly texture, that orange peel, as the solvent flashes out, it's going to allow that skin to shrink and tighten and smooth out the coat. So maintaining the wet edge is critical. We have to get all that work done before it flashes, which means the area that you can apply at any given time is dependent upon your environmental conditions. So if it's 10% humidity and 90 degrees, you might work on an area this big.
Right.
But if it's 60 degrees and 60% humidity, you might be able to paint the whole thing and have to wait for it to flash.
And it seems like just as important as the tool and abrasive kind of paired, quality of roller and devices like that make a big difference on the quality of the top coat.
100%. You have to match the roller to the material. And every manufacturer will have some suggestions. You should follow those suggestions. Listen to Gentry because she knows what's the right roller for the right material.
Okay, very good. And so any other comments, Gentry or Alfred, around kind of what we just talked about as far as the materials or the techniques? I think we've talked through most of them, but we have a moment or here.
Well, whenever you have tape applied and you're using it to create a boundary for your paint, make sure you remove it before it flashes. Yeah. And just if you're going to paint an area and then you're going to move to the area next to it, that you need to blend those two areas, and that first area should not have flashed yet. So those are the criteria that determine how much work you can accomplish at any given time.
Yep, for sure.
And apply the paint. Most people don't. They put it on and they try and spread it super thin. They try and make their discs last an hour. No. Let's put it on. Let's cut it out.
And just make sure you're using a quality roller cover, and that's why we have a variety of roller covers to choose from.
I learned a lot from you about the types of roller covers that were out there.
Yeah, we sent, I don't know, 5, 6 different ones to the shop.
Depending on the material that's needed.
Yeah.
Thank you very much.
So.
All right. So that has been a great conversation. I hope you guys have enjoyed it as much as we did, along with all of the video content support that we're talking about. We're doing really well on time, so we do have some moments for some questions and answers. Or questions, we'll see how we do with answers. It'll be up to you guys. I'm going to be the... first question, what are the lead times for the products shown today?
That's a good question. So typically we have all the materials in stock, and it's just, transit time to get materials to sites, which is typically about 2 to 3 business days. So
that was the question that I got. But is that the same for the resins and the brushes, or is there a different lead times for different kinds of materials, or?
There can be. However, we go based off of historical usage and insights into the upcoming repair season, and make sure that maybe materials that are manufactured overseas we have in stock as well.
So we know what happened last year, and we rely on these people to tell us what they think is going to happen this year.
Yes. And
somewhere there's a crystal ball that we try and stay ahead to make sure they have what they need when they need it.
Yep.
Okay.
Absolutely.
Good. All right. Alfred, I guess this is to you. How many students can you have at a time?
Oh, that's a great question. Optimally, 8 at a time is perfect. We can do as many as 16 at a time if they are all in the same curriculum. We have especially like our boilerplate curriculums, level 1 and level 2. When we get into the advanced curriculums, we're trying to do something a little more bespoke.
Okay. Can you ship internationally?
Yeah, so we have customers that are based all over the globe. We can assist with international shipping, so if you have questions, just reach out to us and we'd be more than happy to help.
We can assist with shipping.
Correct.
Okay. And then do you have focused training for other issues like leading edge repair or transverse cracks?
Oh, great question. So at Blade Repair Academy, we have 120 hours of curriculum that is standard. 40-hour class called Level 1 Support is for entry-level technicians coming into the trade. They're going to come out with some skills that are great for support, like the filling and the fairing and the top coat.
Mm-hmm.
Then we have level 2 execute, which is going to challenge a trainee to get through a window repair, which includes the vacuum compaction and core replacement and all that. We have a 40-hour infusion competency course. We have, when you're talking about transverse cracks or other repair types, we do that on a custom basis. As a client asks for it, we can build them the curriculum. When you're in the advanced training, we liken it to a professional athlete who needs to come in and focus on a particular skill or muscle group or whatever the case may be. So at that level, it's bespoke.
And you do both classroom per se work and then also hands-on, right?
That's right. We have a learning management system that allows us to offer an online curriculum for, competency training and stuff like that. It's important to us that we deliver our content in lecture, and then we have slides and videos, and then we have hands-on demonstrations. So we try and make sure that we cover all the different bases. And we have, our clientele are often from different cultures and have different languages. And we speak Spanish, and we can work with Brazil, with Portuguese a little bit.
Great.
So we try and make sure we can accommodate everybody's learning style, and they have the time to do what they need to do to make it happen.
So we have another question here. I'm just watching the clock. I think we're going to try and answer maybe a couple more here. Can you elaborate more on the VMS3 and Combi? What are the step process advantages, and what are the final quality advantages?
Ooh, okay. Well, the step process advantages are, now we're talking about these materials in the vacuum compaction role. And so on a repair, if you have more than 3 layers, if you have spar layers, you're going to have to vacuum compact it. The process benefit is that instead of staging 3 separate materials here, like polyester breather,
Flow media,
right, peel ply, it all comes in one. And on blade, it's super handy to be able to just unfurl that and deploy it. So rather than putting 3 components in, we can just do one. The VMS is an additional element. Most people would take a vacuum tube and just stick it in the bag with some breather on it. And sure, it's going to pull, but it's not going to filter or prevent resin from entering that tube.
So there's danger of drying out your resin and plugging anything else you got in your line. So quality and efficiency both go up by using these materials.
Yeah, the finish improves. This, this is going to pull air out. Resin can't get through here. This infusion mess has a certain capacity for resin. And as a technician, we can get to know that and have a liberal amount of resin in our repair that we know this will bring to the surface, and it gets on this side of the peel ply, and then we can remove it after it's cured.
Okay. We'll try and get through as many of these as we can. And again, what we can't answer right now, we'll follow up as they come in. What's your opinion of hard roller usage as opposed to strictly using a scraper?
Hard rollers typically come from the dry layup modality. When we cure under film and work glass under film, it's not as useful of a tool.
So the wet layup process,
I'm using a spreader
rather
than a roller,
because it gives you better
and the spreader
compression.
doesn't get dirty, and I don't get dirty. The plastic gets dirty, but I roll that plastic up in on itself and dispose of it. There's more trash, but there's less mess.
Okay. When applying the PU or paste, should it be applied in one direction, up and down, or side to side? Does that matter much?
That's a good question.
That's a good question. My theory about using a spreader on a blade in a vertical position is there are 3 axes that we need to deal with, or 3 issues. There's left and right and up and down, and then there's gravity. So I like to move the strokes upward because that kind of puts the payload onto the spreader, and I can have a large clump on the spreader, and if I'm moving up, it's not going to fall. But if I'm moving down with a large clump, the clump can drop out from you. So upward strokes using gravity to your advantage is the way I like to do it.
But what if you're using a different filler that you would use a roller for? Would it be the same up and down, or?
You wouldn't use a roller with a filler. That'd be with a resin or a lamination.
Sorry.
Yeah.
So maybe the question is with the top coat,
With the top coat.
same approach.
Yeah.
I use that same approach on everything I do. When I'm working a laminate down under plastic, I'm thinking about I'm moving out radially with my strokes to evacuate air, but a third of my strokes are vertical to compensate for the fact that it might be sliding.
So I think it's comical that you're 200 meters up in the air and gravity is your friend. You're using it to help with, there's some kind of an oxymoron in that.
It is.
All right, so we still have a few more time, a few more questions. Why do you recommend step scarfing over smooth chamfer sanding?
I recommend, well, I'm not saying that smooth chamfering is another additional step, but it depends on really who is asking you to do the work. So I'm sort of ambivalent on step scarfing or chamfering. Really just depends on what your work instructions are. I would chamfer after step scarfing. We just didn't have the opportunity to go through every little step here. We didn't talk about inspection determining BOD, but that's what you all come to my shop for.
All right. So this will be the last question, and it says, do you have plans to build on this with another webinar? And then I just lost whatever. Oh, that's sorry. Hang on. And so, yes, this may be the first time we're doing this, but as you saw, we recorded the entire repair process. And so there are opportunities for us to collaborate more on deeper dives into individual steps or to other kinds of topics that would be of interest to this kind of an audience. And so this will be our last question, and then we're going to have to say goodbye for today. But how long should a vacuum compaction be applied? How long do you have to hold that vacuum to be confident?
Well, till it's cured. And if you're post-curing,
Smart
you
aleck.
need to include that cycle in it. I mean, it's smart alecky, but it's true. Until it's in a solid state, the vacuum is doing work. And once it's in a solid state, it's not. But I'm not necessarily going to unbag it to throw on a heat blanket. So I just keep the vac on and apply the heat after it's gelled.
Okay.
And then when it's finally cured, all that can come off.
All right. So Alfred, thank you so much for joining us today and for all the work back at the Academy, prepping all these things. And Gentry, thank you for being here.
Thank you, Brett.
As I look out on the group here, I hope this has been fun, interesting. Maybe you learned something about the materials and some processes involved in blade repair. Thank you for joining us today. We'll look forward to seeing you throughout the wind season. I hope it's a very prosperous and productive one for each and every one of you. Thank you.
Thank you.
Thank you.